to introduce. And I want to tell you about the rotary motor and the bacterial flagellum, which sounds complicated, but don't worry, hopefully I'll help you through it. But it's actually something I found really, really interesting. And I have been told by Ms. Cartwright to acknowledge my bias, and part of that is I am a Christian, and I do believe in a creator God, and not cross-species evolution. But that is part of the reason I wanted to do this, because there is a lot of controversy over this topic, and I just wanted to take a look at both sides of the evidence. So first of all, I'm going to clarify the theories I'm using. Most of you probably know evolution, the belief that genes change over time, from parents to children to their children, because of mutation and natural selection and genetic growth, which is also changes in genes. And then intelligent design is the belief that things in our universe are from purposeful design by an intelligent being rather than from chance or undirected natural processes. This is E. coli. There are strings, string-like things, coming out of the cell. These are flagellum. E. coli isn't the only type of bacteria to have them, but as you can see, this one does. There's a place seemingly randomly around the cell, and scientists don't know what it is that causes the cell to place them in the places it has. When the flagellum spins, it propels the cell away from waste and towards nutrients. The way it spins is by the rotary motor of the bacterial flagellum. This is where it would be on the cell. If the bit coming out is the flagellum, then where the arrow is pointing, beautifully drawn by myself, would be where the rotary motor is. But just to give you an idea of scale, this is 27 nanometers, which is 0, and then 0.00027 centimeters. Very tiny. It's attached to the internal parts of the cell and the external parts of the cell for extra security so it doesn't spin out. And this is what it looks like in real life. I just think that's an amazing picture, and I just think it just shows how incredible we've made it is. It spins at, I think it's made that. 1,700,000 RPM, which is actually 1,000 times faster than a jet engine. And it can last, spinning like this, for 2 years. The parts that move have a water cooling system, like at nuclear power stations, so it doesn't overheat. And it's powered by a positively charged particle, a proton, which causes a charge difference across the very inner ring of the motor, which makes the rest of it turn. However, we're not entirely sure why this works. The cell gets feedback from the motor from chemical pathways inside the cell, like roads which have chemicals on them, so it can give directions such as stop and go. Now this is a bit daunting, but this is a table of the proteins that must be in the flagellum for it to work correctly. They must be there in the correct amount, at the correct time, and if they're not, there will be blockages when it's being made, so it wouldn't be formed properly. Some components may have other proteins to help it be there, such as regulator or chaperone. That's the proteins that do that. Don't worry, I'll bring you that later, so don't try and memorize them. Okay. The main key for tracking evolution is similar proteins. As if they're similar, they can be thought to be somehow related. And when a protein is similar enough, it's described as homologous. That basically just means similar. There are thought to be many different types of motor, but they're all roughly the same. From evolutionist point of view, this is given as evidence of a common ancestor. But for intelligent design, it's actually given as evidence of variation within a kind, which is only changes but within a small range, such as all cats produce cats, but they're all a bit different. In a study of the proteins, which I showed you earlier, it was discovered that 23 out of the 40 were present in most bacterial species with the motor, though there were a few variations. And this led people to believe that there may be a set of proteins somewhat similar to the 23 we see today that make up an ancestral core flagellum. And in 2 studies after that, people thought that there may be evidence of similarity even within those 23, and that they may come from a single gene. But other scientists came back and criticised this because the proteins that were found to be homologous were actually different shapes, which is evidence against them being similar. This is the type 3 secretory system for evolutionists use to combat the rotary motor of flagellum, sometimes being described as unique. It's found in certain types of salmonella, and it's used to transport poisons into a host. It's said to be somehow related to the rotary motor. It's made of about 15 to 25 proteins, but the rotary motor, as I said already, is made of around 40. Together, these two, which is also that's another picture, the rotary motor, share 7 proteins, though they are variant. In the rotary motor, these proteins cause flagellum to move through the centre part at the bottom and up out of the outer membrane to form the actual flagellum. In a similar way, the proteins in the type 3 secretory system move toxins out of the needle. These shared proteins lead evolutionists to believe that the type 3 secretory system and rotary motor have a shared ancestor. It's also suggested that the presence of these proteins destroys a claim that intelligent design makes, which is called irreducible complexity. It's a theory stating that if any part were removed, it would no longer work. The type 3 secretory system is viewed as a partial flagellum, and therefore evolutionists believe that proteins of the bacterial motor can still make something functional when they're on their own. Intelligent design has another argument for this. It focuses on complexity and uniqueness, which is why I brought you back here. Complexity is important because if something is too complex, it requires almost all of its parts, and therefore it cannot be simplified enough to see any ancestor it may have come from. Uniqueness is important because if the parts don't appear anywhere else, they cannot be borrowed from a pre-existing system. Out of these 40 proteins here, the rotary motor cannot do without 20 of them, and 11 of them are not found anywhere else. Out of the 20 that it needs to be fully functional, 2 of them are unique. These are FLGD and FLIE. It is not possible to make the rotary motor without them, as I said. The argument intelligent design uses is, if the proteins cannot be found anywhere else, they must have been designed by an intelligence. Evolution works on the basis of natural selection, which demands that only small change can occur at a time. Each change must provide some sort of advantage to the cell, or it is eliminated. Intelligent design argues that if this bacterium had the ability to attach a flagellum to itself, it wouldn't be passed on if the bacteria could not produce the flagellum. Natural selection would probably eliminate this, as it's not advantageous to the cell. Intelligent design then says natural selection can favour the flagellum. Sounds like ice cream. Sorry. But only when all of its parts are present. This is only because in a fully functional state, it provides such a great advantage to the cell that if there are a few parts present, often you don't have anything functional. The co-option theory, one of evolution's main arguments, states that the proteins and systems can be taken from something which already exists, if favoured by natural selection. The type 3 secretory system, if it preceded the flagellum motor, which is also up for debate, would have been favoured by natural selection in its complete state. Parts of it, namely the flagellum protein excretion system that I described earlier, could have been used to make the rotary motor. However, intelligent design poses the question that there's only 7 variant proteins shared by these two systems. Where, therefore, have the other 30-ish proteins been borrowed from? They go on to conclude that if the proteins couldn't have been borrowed, they are unique and must have been designed. Intelligent design also cites irreducible complexity. It's a theory by Michael Behe, who studied the rotary motor for most of his life. The theory says that something is irreducibly complex if it is a single system composed of several intricate parts that contribute to basic function, and where the removal of any one of these parts would cause the rotary motor to cease functioning. It's clear that out of the 40 proteins, 20 are indispensable. The rest could be removed, but once at base 20, the rotary motor really does cease to function. In the eyes of evolutionists, this has disproved the claim of irreducible complexity. However, there is another aspect of the rotary motor which is also said to be irreducibly complex, and that is its assembly. As I mentioned previously, it requires specific parts in a specific order and at a specific time. Not only that, they must be put together in the correct order and be present in the right amount. To ensure this, there is a feedback system, which makes sure that once part of the assembly is complete, production for the protein required stops, and it moves on to the next part. The feedback system also lets the bacteria know if the rotary motor being assembled will function. This is so energy is not wasted in building something which will not work. This feedback system is also not understood and cannot be explained. As the assembly also involves the chaperone proteins, which I told you about earlier, they help make the overall structure